All right. So this is when I actually start teaching by sections, because 5.6 and 5.7, that was kind of a review. But what I will do is break down the section or break down the chapter and how we're going to go over. I'm looking for my, there it is. In pre-algebra, or math in pre-algebra, you learn how to deal with fractions. Now, when you dealt with fractions, you learned what a fraction was. 3/4 is equal to basically a pizza pie cut in 4 pieces, and you eat 3 out of 4. Or you eat 1 and 3 out of 4 is left, whichever. So you were taught that fractions were a number over another number, and that was a 4/over ratio. And you were taught that you could change 3/4 into something 16th by going 4 will go into 16 4 times. 4 times 3 is 12. And you were told you could go the opposite way. You could reduce it from 12/16 down to 3/4. And you were told that you could also take 12 and make it 2 times 2 times 3 over 2 times 2 times 2 times 2, and what could you do? You could cancel, and that would give you 3/4. Okay, so you were taught the definition of a fraction. You were taught how to mathematically manipulate and reduce. You were taught how to do that. Mathematically manipulate means you know how to reduce it, you know how to make it into a bigger fraction, or you know how to cancel. Then you were taught how to, let's go with 1, the definition. 2, how to manipulate it. 3, you were taught how to combine. And by combining, you had to get a common what? Common denominator. And 1/4 plus 2/3, and that would be a 12 here and 12 here. 4 will go into 12 3 times. 3 times 1 is 3. And 3 will go into 12 4 times. 4 times 2 is 8. And 8 plus 3 is 11/12. And you were taught how to do that. And you were taught how to multiply fractions, which was real easy. 1/2 times 4/3. You could use the what? Canceling. And that would lift you with 2/3. And division wasn't that big of a deal because there is no such thing as division, because you multiply by the reciprocal. So 1/2 divided by 3/4 is equal to 1/2 multiplied by 4/3, and 4's cancel there with 2, and you get 2/3. So all of this stuff that we're fixing to go into, you've learned before. Okay? Now, it's just not going to be with numbers, it's going to be with trinomials. or polynomials. So let's go ahead and look at a polynomial. It's called a rational expression. Huh? I forgot my SD card. It's my camera's in the office, but I forgot my SD card there at home. I thought they were in the truck, but it wasn't, and I forgot to check. But I appreciate, I know my camera is glad that y'all are thinking about it. Rational expression, huh?
I just thought someone would use
Yes.
it.
We'll have to go by the computer today. So there'll only be one post today for the one or two people that actually look at it. But all right, rational expressions / equations. First of all, what is a rational expression? Well, I'll give you an example of one. X plus 2 over x minus 3. That's a rational expression. X over x squared plus 3x plus 2. That's a rational expression. X squared plus 3x minus 7 over x plus 2. That's a rational expression. So all of them are rational expressions, but basically just what? Fractions. Only instead of numbers, you have variables. Now, what do you do with these things? Well, you really can't do anything with these because they're already simplified. But if I said that x was 5, plug and chug, you get 5 plus 2 over 5 minus 3. And that'll give you 7 over what? So you can plug and chug. You can evaluate. You can, that's about all you can do with these. In some cases you can cancel. I give you 12x squared over 4x to the 5th. Well, you can cancel there. You can break that up. Now I'm going to show you the long way of doing it. 3 times 4 times x over 4 times x. And then of course 4's cancel. And one set of x's and two set of x's. And what's left? 3 over x to the third. Now you could have got that also by 4 divided, 12 divided by 4 is 3 over 1. This cancels with 3 over 1. And then 2 minus 5 is negative 3. The negative 3 is up here. And you bring that down, and that would be. So you've got 2 or 3 different ways. Anytime you're dealing with rational, anytime you deal with rational functions or rational expressions, you've got different ways you can do it. Okay, you can do it the long way. You can do it using the quotient rule. You can bring this up here. You can bring this down here using the inverse rule. There's 4 or 5 different ways you can do these problems. All right. So, definition basically is a fraction. What can you do with a rational expression? Well, the most basic things you can do is you can evaluate if they give you an x or a y or whatever, and then cancel. You can simplify it as reducible. Those are the 2 basic things. All right. So, 1, we can evaluate. Then evaluate is a 25-cent word for plug and chug. 2, we can simplify or reduce if reducible. And then what else can we do? Well, we can do all those other things that we did with fractions before. Okay, we can add, subtract, multiply, divide, and we'll say 3 combined. And 4 multiply. Now really, that's all you got, because what is division? Multiplication by the reciprocal. So really, this is it. Now I'm going to cover, I've covered a little bit of this one and this one. I'm going to save this one for last because this is more complicated. We're going to go to multiplication and division next. I think that's 6.2. Because this is 6.1. And 6.2 is right here. So we're going to do 6.2 now. And when I get through with 6.2, we're going to go through and do some homework problems out of both before we move on to 6.3. Okay? So, let's look at something that you might see. X plus 2 over x squared times x to the 4th over x plus 2. Now, one thing that I tell students, when in doubt, write it out. When in doubt, write it out. So let's do that. X times x times x times x, that's that. And I'm going to put all that over x plus 2. And then times x plus 2 over x times x. Now, if we was to put all this together, 2 times x is 2x, right? 3 times 6 is 18. So I can put these two together and say this times this. So I could say x plus 2 times, with parentheses, x times x times x times x over x plus 2 times x times x. And what happens? And what's left? Now, that's one way to do it. That is the most basic way to do it. That is, I have no idea how to do it. I'm just going to write it out, and I'm going to cancel. That's the basic of the basic. So that's one way to do it. Okay, so one way. And I'll just say basic. So even if you don't know how to do things, with different rules, you can just write it out and pick. 2, we can use cancelization. In other words, not writing everything out, but just canceling it. So x plus 2 over x squared times x to the 4th over x plus 2. Instead of writing it all out, you could have went x plus 2 cancels, and that x squared cancels with that x squared, and that leaves x squared, so that's what my own. You could have done it that way. You could have used exponents and brought everything up here. Could have done that. Let me show you that. Let's see, x plus 2 times x to the negative 2 times x to the 4th times x plus 2 to the negative 1. Use your quotient rule and brought everything up to the top. So that'll be x plus 2 times x to the negative 2. I brought that one up. Times x to the 4 times x plus 2 to the negative 1. Now add exponents. X plus 2 to the 1 minus 1, and x to the negative 2 plus what? 4. And this gives you x plus 2 to the 0 times x squared. And what's anything to the 0 power? So your answer is any time in chapter 6 you're dealing with these problems, except for a couple of sections, you can do it several different ways. Should you come out with the same answer? Yeah, you agree? Yeah. So multiplication is real simple. Well, where's the catch? Well, sometimes you're going to have trinomials. And trinomials, and write this down, this is a very important part of this section, because of this chapter. Especially in this chapter. No talking, please. Trinomials are worthless unless you what? Factor them. So remember that when you're doing these problems. If you see a trinomial, chances are you're going to have to factor, especially at the beginning of the problem. Give you an example. All right, try that one. All right, you should be doing it. Why? 2 what? Shortcut number 1, shortcut number 2. This is how you should do it. X plus 2, quantity squared, over x minus 6, times x minus 6, quantity squared, over x plus 4. This is supposed to be 2. I messed up. I knew something wrong there. It's going to look better. And then what happens to after that? What happens to some of them after that? Well, this one will cancel with one of these, and that'll make it x plus 2 to the first power. And then x minus 6 will cancel with one of these and make it to the first power. So your final answer is x plus 2 times what? X minus 6. Now, if you didn't learn the shortcut in the first unit or first test, you're going to have to know it here, or you will not finish the test. Okay? So you're going to have to learn. Now let's do a division. Well, let's go back to, let's remind ourselves what division is. 1 over 2 divided by 3 over 2 is equal to 1 over 2 multiplied by what? 2 over 3. That's what you learned, your basic rules right there. Divide by a fraction, you multiply by the reciprocal. So if I give you the same thing with a rational, you should know what to do. You just have to bear with me a second. So, this is shortcut number 1. So that's x plus 2 over x plus 3, quantity squared, multiplied by x plus 3 over x plus 2, and what happens? One of these cancels, so that means you got 1 over x plus 3. You have to. There's no other way to write it. Unless you want to write it as a negative exponent. You could do this. That's a no-no, though. Most teachers would frown upon that. But, in calculus, you're told to do this. Because you take the derivative of this, you can take the derivative, the antiderivative of this easily here, which can't do it. So they tell you to rewrite it as a negative exponent in calculus. But they don't tell you to leave it like that. They tell you to write it like that so it's easier to work with. Alright. So, before we go over addition and subtraction, I want to look over some problems in your homework, and let's just do some so you'll have them in your notes to use. And I'll try to find ones that are aggravating and more challenging than some of the easy ones we just did. Yeah, just get mad and leave. Okay. All right, 6.1. No yawning, please. You can only breathe in here, that's it. Alright, simplify that one. That's a test question. But I can tell you right now, I'm not going to put a lot of these on the test. Vanna, just hold on. Hey, come on, give me a second. Yeah, see
I'm
that?
like, where is it
Yeah.
at? Pulling up.
Vanna! Now you know why I give it to Vanna. Casey! Give me time to pull it up. 6.1 will probably be the least on your test. Yeah. Remember, I'm trying to get you to fail. I'm trying to discourage you as much as possible. Yep.
I get this a lot.
Okay, now why you got a calculator out, Hoss?
Will be?
Both of you.
Oh, because I don't know what's
Okay, let me ask you a question. What are they Indian?
But
So
I
they're
was
both,
just-
okay, well, we'll stop.
I was just checking to make sure 75.
They're both divisible by 5, so start by 5s. That's called your brain. Use your brain.
I was trying to use shortcut method number 10 and make sure 75.
Shortcut method!
For 10. Make sure 75 ain't going for it.
Alright, they're both divisible by 5. Now, I'm going to show you a trick of learning the war. 5 will go into 40 8 times in one time, 81. So that's 81 at a time. Well, keep going!
I was just trying to make it easier on myself.
Say it again.
I was trying to make it easier on myself.
Yeah, that's another word. That's another way of saying lazy.
See the 75 doesn't work?
Okay. 5, I just said that they end in 5, right? So 5 will go in both of them. 5 will go into that one 8 times. And 81. So put 81 right there. And 5 will go into this how many times? Well, let's see. 1 time, 15. 15. 81 and 15. 3. Now how do you know that? Well, 81, it ends in a 1. What's the only multiple in your multiplication tables that end in 1 besides 81? 3. Dang old firing out here.
Yeah.
Dang old making it fire, making it work. What's this 6 for? Well, that's good. Mr. Head, I take on you. You can take it. You're picking up. You've been through it.
I have 2 brothers too, so.
Believe you me, when y'all need that calculator, I'll tell you to get it out. But right now, we don't need it. All right. Bring it down, Vanna, please. All right. So, I'm just going to, when you have one of these, the best thing to do is separate. Especially if you get overwhelmed with looking at a problem. Some of you might be that way, because I used to be. This is what I do. Is there any rule that you can't rewrite, separate? No, there's no rule. Now, like I said, you can do this many different ways. You could bring this 3 up to the top with the inverse rule. You can bring this 7 down here with the inverse rule. You can use the quotient rule. Same thing here. Or you could write it out. B times B times B times B times B, 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 and then cancel out if you want to do it that way. The main thing is do whatever you want, because there's not going to be a lot of these on the test. There may be 2. All right. So let's go with 5 here. That'll be a 81 and a 15. I know 3 will go into that one and that one, because 3 times 27, I believe, is 81. Or check me on that. 3 times 27. Is that right? So that'll be 21 over what? 5? So that's it. How do I know that's it? Because 5 is what? Prime. And the only number going in is 5. So that's not what 21 is not going to help you. So that's done. You're done there. What's 7 minus 3? B to the 4th over 1. And this is 21 over 5. And what's 5 minus 3? Z to the 2nd over 1. So your final answer is 21 B to the 4th Z squared over 5. Or you could write it 21 fifths B to the 4th Z squared. Either way. Now, if I give you 20 questions on the test, you're probably talking about 2 being like this. Most of your problems are going to come out of 6.2 and 6.3, and I think there's one other section. Complex rational expressions. All right, try that one. What shortcuts? 3 and 2.
I didn't know.
Oh, just quit.
I quit. I'm leaving.
Cardboard box in the ditch. Life's not fair. It never was, isn't now, and won't ever be. Do not fall into the entitlement trap of feeling like you're a victim. You are not. Who said that? It was just said like yesterday. Matthew McConaughey. He did a commencement speech. Do not fall into the entitlement trap. True. Just like that guy said from England. I grew up working hard, and I got what I got by working hard. Imagine that. No, you're supposed to get mad at somebody because they worked hard all their life and got something. You're supposed to get mad at them. I don't understand the way people think.
The only ones I get mad at are the schools I think that maybe everything.
Well, that'll take care of itself.
Oh, I know.
It takes care of itself. And you're also talking about kids. I'm talking about adults.
Well, yeah, they're always kids.
You should not, just like people got mad at Mitt Romney because he's done well. But so has Hillary Clinton, but do you hear anybody say anything about Hillary Clinton? Nope. To be president of the United States, you have to have what? You have to have money. Okay? Nobody said anything about Obama's money. Nobody. Nobody said anything about Hillary's money. Nobody said anything about Bill's money. But they brought up about Romney's. Why? Because he's Republican. You can be a rich Democrat, it's okay. But you're a rich Republican, you get chastised. I don't think that's right. Bring it down, man. What's good for the goose is what?
Good for the gator.
Good job. Good parents for the well. All right.
I
S.
guess my husband was a gator once.
Oh my Lord. What's a drake? What's a drake? How'd you know that? Your parents did well. S squared minus 1 over S squared minus 2S plus 1 is equal to S plus 1, S minus 1 over S minus 1 quantity what? Squared. And what happens? That cancels with one of those, and you get S plus 1 over what? And you feel good about yourself. Huh? For a second, until I discourage you. So I kick you while you're down, kick you in the stomach. I play football. Yeah. That's the same type question right there. All right, you want to see a test question? That was a test question we just did. Here's another test question, which is the same thing, only the, yeah. They will start throwing rocks in a minute. You just give them time. They will. Oh. You had to sit on this side, didn't you? Yeah. That's a gaggle.
Female.
Isn't that a gaggle?
No, I've researched.
Ain't that a gaggle?
I think there's still called like a block also.
I think it's called a gaggle. Let's look it up so we can learn something. I'll look it up after y'all finish. Take y'all an hour to write that down. I'll do it on my phone. Flock of geese is a gaggle. That is not in flight. So I guess that's when they're smoking and joking. Drinking beer, yeah. What are you talking about? Yeah, that's for like people in wheelchairs. I don't know if I said that politically correct or not, but people in wheelchairs. Alright, bring it down, please. That's shortcut number 3. Z minus 4 squared over Z plus 4. Z minus 4. So that's Z minus 4 over Z plus 4. All right, so let's move on to 6.2. Unless I see something, let me look and see if there's anything else that I need to. The same thing. Same thing. Take out a factor of -1. Yeah, these are all the same. All right. (6.2), you're talking about more problems on the test. And they're not going to be the easy ones. They're going to be the ones at the end of the... Notice how many is in this study plan. This ain't your homework. This is a study plan. Notice how many there are. Wonder why there's so many. Because they want to piss you off? Exactly. Because, like I said, this area right here is just like a musical instrument. It ain't like graphing. You know, you do graphing, you do it 5 or 6 times, you know it. And you're okay with it. This is not like graphing. This is like playing a piano. Yeah, pulling your hair out too. So, let's look at one fairly easy. All right. This one's multiplication. What did she say? I don't know who it is. I don't want anybody to say, that I'm loud anymore. No, I don't know. Don't know. Alright, bring it down. So b plus 5 times b minus 5, shortcut number 3, over 2 times b plus 6 times b plus 6 over b minus 5. Now what? Start canceling. We're left with b plus 5 over 2. So, what does all this mean? Well, let's say that b is equal to 1? Well, what's 1 squared? 1 squared is 1 minus 25 is what? Negative 24. 2 times 1 is what? 2 times 1 is 2.
Sorry.
Plus 12 is 14. What's 1 plus 6? And 1 minus 5? And that will cancel there, what, 4 times, I mean 6 times? And that will cancel there 2 times, and what's 6 divided by 2? Or you could just plug in 1 right here and get 1 plus 5 is, and 6 divided by 2. And what you've done is you just basically, let's go back. Remember this? 3/4 is equal to 12/16. What we just did is we just took this out, 4 will go in there 3 times, and 4 will go in there what? We just went this way. But you'd be surprised at how many people do these problems right here. Do these problems right here, and they'll do all of this, and they'll do this, but you ask them what they have at the end of the problem, they go, oh no. They have the same thing that you what? What you started with. Where? You can't, this does not go into this. This is 1/2 times b plus 5. That's what that is right there. Those are the same thing. So technically, that 1/2 is distributed. It would be b over 2 plus 5 over 2. And once you put that 5 over 2, then you can change it to 2.5, but I don't know why you can do that. Try that one. Hold on a minute. Go back down. I gotta get rid of all this stuff. Remember, factor everything. Even if it's something simple like 2 times 2, factor it. As you may see something cancel out. Remember, you can cancel diagonally and you can cancel vertically. 16y, you could write it as 4 times 4, y times y, or y squared, whatever. You don't have to do that. That's just something that, you know, some people might want to do.
Would you write it as 4y times 4?
Yes, you can write it like that if you want to. This right here, I'm going to factor out a 2. That'll give me y squared minus 4y plus 4. And I know I can factor that. I'm just going to, just wait a minute. 2 times y minus 2 over 4y. And this is shortcut number 3, 2. 4y times 4y, if you want to do it that way. 2 times y minus 2, quantity squared, times 2, y minus 2 over 4y. And you can take your handy dandy pencil and marker, and the 2's will cancel. The y minus 2 will cancel with this y minus 2 and leave that as a y minus 2 to the first power. And one of these 4y's will cancel with one of those 4y's, so your final answer is 4y over y minus 2. So if I give you 20 problems on a test, you're talking about 3 or 4 coming from this section. Student nerd. Oh yeah, that ought to really discourage some of you. I'd quit. Throw your pencil down. There you go. Just quit. Don't even try. Blame it on Bush. been trying to find the access code from MyLabs Plus, but I can't find it. Where is it? Where's the access code for MyLabs Plus? In the bookstore, online. All right, y'all got it? So, reverse FOIL, X, X. Looks like a 6 and a 4. And we need a -6 and a unlike sign there. Shortcut, nope. Reverse FOIL. I can't mess that 1 up. If you mess that 1 up, you're doing very good, because I don't see how you can mess the 1 up. And then a 1 here and a 3 here. So that's going to be an X and an X there. We need a +4, so that means the 3 has to be positive. And this means like, so that's positive. Right here, reverse FOIL again. So that's going to be 3X or 1X. And 3X. And 1 and 1. This time we need a negative. So that means the 3 has to be negative. And this means unlike. So that has to be positive. And then this looks like X and X. And we need a 6 and a 4. Now what? Cancel all you want. If I know X plus 4 cancel, let's use red canceling pencil. X plus 4 is canceled. X, 3X plus 1 is canceled. Anything else? Nope. So your final answer is X minus 6 times X minus 1 over X plus 1 x plus 6. That's it. Now, a lot of people ask me right here, why don't you turn it into trinomials? Well, usually when you get it to that point, you're canceling, so you just leave it like that. Now, some people might want to change it, but it says type your answer in what? Factored is not a trinomial. This is factored form. So let's type in a 3, and let's show you that I know what I'm talking about. Oh, shoot. Okay, I just hit the... Oh well, I'm sorry. I hit the close button instead of submit button. I suck. I don't know what number that was, but... Oh well, we gotta move on anyway. 6.3. Now this is where we're gonna get into the fun stuff. This is where we get into the adding and subtracting. Now before we get into it, and I'm really gonna wait till y'all come back tomorrow, but we're gonna start with pre-algebra adding and subtracting. We're gonna start with that first because we gotta kind of warm you up. So let's go back to pre-algebra, and when you reviewed over your fractions, and let's start with something simple. 1/2 plus 3/4. And the common denominator is what? 4. So 4 will go into 4 one time. 1 times 3 is 3. 2 will go into 4 how many times? 2 times 1 is, so 2 plus 3 is 5/4. Now, I'm not doing this to insult your intelligence. What I'm doing is showing you what to do when you need a common denominator. You follow these arrows. Some of you do this. Some of you 3/4 plus 5/3. And some of you do this. 4 will go into 12 3 times. 3 times 3 is 9. 3 will go into 12. 4 times 5 is 20. What's our answer? 29 over. Some of you do that. I don't care which one you do. Just so long as you know what to do. Alright? Alright, so this is our basic math review. Usually you did this in pre-algebra before you started on algebra. Then the algebra came along and you did something like this. 1 over x plus 3 over x squared. And that's when the teacher should have told you that whenever you want a common denominator with exponents, you go with the largest what? Exponent. You go with the largest exponent. So the common denominator is what? X squared. X will go into x squared, x times. X times 1 is 1 times x. X squared will go into x squared 1 time. 1 times 3 is 3. So now your answer is x plus 3 over x squared. So this is still pre-algebra. And then your pre-algebra class said, well, let's add something to it. 2 over x plus 3 over x plus 1. And that's where you, just like the 21, what happens when you have 3 and 7 as a denominator? Well, they have nothing in common, so you what? You put them together. So that's what you do here. And when you multiply x times x minus 1, you get x times x minus 1, or x plus 1. So you just put them together. No, you don't have to distribute them. Just put them together. Put them side by side. So that's going to be x times x plus 1 as a common denominator, and x times x plus 1. How many times will x go into this? X plus 1 times 2 is 2 times x plus 1. Follow the arrows. X will go in there. X plus 1 time. X plus 1 times 2 is 2 times x plus 1. Same thing you've been doing since pre-algebra, only you've got it longer. How many times will x plus 1 go into this? X times 3 is 3x. Combine the top and put it over one denominator, which is the one denominator will be x times x plus 1. So you don't have to worry about the denominator anymore. It's done. You just got to clean up the numerator. Now you can distribute that too. So what do you do with that 2? 2x plus 2. You distribute that 2. And that'd be 2x plus 2. And what's 2x plus 3x? So that'd be 5x plus 2 over x times x plus 1. And that's your final answer. Huh? You can if you want to, but they probably won't. They'll probably leave it like that. Most of your answers here are going to be in factor form, meaning that right there. And that's when you had 2 different denominators. And then they moved you up a little bit, and they said, well, let's do one like this. 2 over x plus 1 minus 3 times x minus 2. Again, they have nothing in common, so you put them beside each other. Find the common denominator, or if you found the common denominator, then change the numerators. So So the common denominator is x plus 1 times what?
X plus
I'm gonna let y'all work on that one.
2.
Huh?
I was talking to something.
You answer yourself.
Yes.
Okay. Notice, what do I do each time? I follow the same what? Same procedure. How many times will x plus 1 go into this? X minus 2 times. X minus 2 times 2 is 2 times x minus 2. I follow that same procedure each time. I do not get off of it. I do not change it. How many times will x minus 2 go into this? X plus 1 times 3 is 3 times x plus 1. Now, once you do that, you've got a common denominator, and then you just write down the numerator. Two x minus what?
4.
Now, what about this negative 3? What does that do to life? It changes things. Changes this x to a what? Negative 3x, and it changes this 1 to a what? Negative 3. And 2x minus 3x is negative 1x or negative x. And negative 4 minus 3 is over, I'm just going to write a squiggle over the common denominator. You can factor out a negative 1 and get negative 1 times x plus 7. If you had x plus 7 down here, you can cancel out the x plus 7, but there's nothing you can do. So, and a lot of times I'm going to write this squiggle, and that means that common denominator right there. It's just something I'll do. But you're still in algebra 1, I think. Okay, because these are, you know, algebra 1 problems. Let's do a derivative. 3 over x minus 6 minus 2 over x minus 6 quantity squared. And remember, whenever you're dealing with exponents, you always pick what? The largest exponent. Unless you want to change horses in midstream and use some other rule like Burdett's rule number 10. Shortcut number 10. So what's the common denominator here? X minus 2 quantity squared. X minus 6 quantity squared. That's no problem. Good. How many times will x minus 6 go into x minus 6 quantity squared? X minus 6 times 3 is 3 times x minus 6. This will go into this 1 time. 1 times 2 is 2. 3x minus 18 minus 2 over x minus 6 quantity squared. 3x minus 20 over x minus 6 quantity squared. Same exact process over and over. Now the only difference is tomorrow we're going to put some different things down here and some more complicated things. Now you're talking about 3 to 4 questions of your test. All right, let me get the roll and then y'all can skedaddle. Y'all got quite a bit of homework to do. You got a test to do, homework to finish up, and homework to start. And I can fill out drop slips whenever you want me to. Do we even use drop slips anymore? Just go to the computer to do it, right? Just like you go to rate my professor to bash the teacher. No comment. I know Miss Turner's not here, so I'm going to go ahead and mark her absence. Anybody else? Okay. Alrighty. Y'all have a good day. Let me get this right quick. Hello. Hey. Just got through teaching. How you doing? Okay. All right. You sent me a text. And what? Okay, well, explain it. Alright, well, be careful. Just got through teaching, waiting on another class. How long do you think it's going to be? Alrighty, well, be careful. Love you. Bye-bye. No, I decided not to.
Okay. Well, I took pictures of my.
You don't have to. I
Well,
got
I
them.
know
I
I
can
can
pull up
do it.
everything. Hold on.
I mean,
Yeah, but I
I've
might as well.
multiple
You need to.
times.
You need
Well,
to know
my
what your
ans-
grade is.
Yeah. Well,
That's why I want to fix it.
all my answers are dumb ones.
That's all right. I don't mind fixing it.
Better not.
Okay, let's look and see. The first one. Okay, that's not a big deal. You just took the square root of 1. All right. scatterbrain.
Yeah. When I write things down, I don't use the little exponents. Or the little letters. That one I switched the terms, so.
Okay.
That one I kept going. I didn't know why
No.
you just stopped.
Okay.
So.
What's square root of 3? I mean, it's square root of 9. Okay. And square root, you can't see x plus 3 and x minus 3. If you take the negative 3 and the positive 3 right here, what does it give you? What's negative 3 and positive 3 get to? Cancel. You wouldn't have a middle term.
Okay.
That's why you can't do
you
that.
can't keep going.
Mm-mm.
And that one I
That's
put
fine.
D's.
Don't tell me you got any of those wrong. I hope you didn't.
No, that was the prime one.
I hope you did that. Because I told you I didn't like to put them on there, so. What did you do there? Did you try to keep going?
Yeah, I think so. I think I always try to keep going.
Alright, that takes
Okay.
you to
I
an 88.
didn't. Okay. That's
Alright?
fine. Okay,
So,
thank you.
alright.
I'll keep trying.
Okay. Bye-bye.
Fans were told there would be no national anthem before the third game of the